if the roots are real and equal, like k and second is also k, then what happened? Then the solution is an is equal to constant capital A plus b into n into that value k and to the power n. It is same like the differential solution, na? In the differential equation also, if the roots are same, then you have built this type of solution, like only the solution is like that, some c1 plus c2x into what, e to the power that mx. Can you remember the solution?
Yes, sir.
The same pattern solutions here also you get from the characteristic roots, just a plus b of n into k to the power n. So we will take one problem on that. We are just writing the recurrence relation and we will solve it. So like solve the recurrence relation, which is suppose t of n minus t of n plus 16 t n minus 2, it is equal to 8 t of n minus 1, and subject to the condition, subject to t0 is equal to suppose 0 and t1 is equal to suppose 4, and then find the value of t of some others point. You can find t of 6 or t of anything like. So now first what we do, tell me. First we rearrange, na, that equations. So after the rearrangement, first take this tn, now take this n minus 1 term after tn, so it will be minus 8 what, t of n minus 1, na, then plus 16 t of n minus 2, and that is equal to 0. Is it clear, the rearrangement?
Yes, sir.
Okay, একটাই yes sir পাচ্ছি, বাকি সব কোথায়? Is there anyone or only Arnav is there?
Yes, sir.
Okay. So now what is the characteristic equation? Tell me, what is the characteristic equation?
X square minus 8x plus 16 equals to 0.
8x plus 16 is equal to 0. So that means x minus 4 square, na, 0. Characteristic roots are x equal to 4 comma what, 4. So the solution is, what is the solution? So the solution is here it is not an, it is tn. Tn will be a plus bn into 4 to the power what, n, na. So it is the solution. Is there any problem in that solutions? If you have any doubt, tell me.
No, sir.
Okay, then from t0 is equal to 0. So t0 is equal to 0 means what you will get? So just put n is equal to 0 here. For n is equal to 0, what you will get? From that equation, t0 is equal to a plus b into 0, that means it will be 0, and 4 to the power 0, it will be 1. So that means you will get t0 is equal to a, or a is equal to 0, na? That is the value of a. Now t1 is given as 4, so that means for n is equal to 4 or not 4, n is equal to what, 1, na? N is equal to 1, t1 is equal to a plus b into 1, that means a plus b, into 4 to the power 1, that means 4. So or T1 value is 4, so 4 is equal to 4 into A plus B, or A plus B is equal to 1, or B is A is 0, so B value is what? 1. Okay, so now we have A and B. So now you can build the solution. So A value is 0 and B value is 1. So the solution is Tn is equal to A value 0 put karo, B value ko 1 bit ko put karo, so only you will get the n. A plus B into n, you will get only n. So n into 4 to the power n. So that is the solutions of the recurrence relation. Now you can calculate any values. If you have to calculate T6, then it will be only 6 into 4 to the power what? 6. Just calculate the value, whatever may be the answers or the values comes, it will be your answer. So it will be 4 to the power 6, 4096, and into 6 is equal to 24576. Okay, is this problem visible to everyone?
Yes, sir.
Okay, so it is a
No.
real life situation problem from where we start, where we apply this type of problem. So here it is given that the tiger population in an area is 30 in the year 1940. So if I start with that populations, so if I start with the population in 1940 as suppose T0, that means it is the initial year, we are taking that. So 1940 is the T0, 0th year, and here the T0 value is equal to what? 30. So it is given 30. And in the 1941 population, in 1941 the tiger population is suppose 2 more, that means the next year T1 is 32. Okay, and by the study over the years, suppose over the left 10 years or 12 years, so they comes to some relations between the tiger populations or the increment of the tiger populations. And what is the increment relations? So increase from n minus 1th year to the nth year. That means if I take the Tn minus T of n minus 1, so it is the increment from n minus 1th year to the nth year is twice the increase from n minus 2th year to the n minus 1th year. So T of n minus 1 minus T of n minus what? 2. So that is the relation between that. So formulate the problem in terms of recurrence relation. So that is the formulation of the problems, and solve it. Now you will solve that and find the number of tigers in that area in the year 1950. So you have to calculate the tigers in the area 1950, what is the populations, or by in this ratio if it change, you can calculate the tiger population in 1917 or 1990 or 2050 also. So that T0, T1, and in this way, so what will be the 1950? It will be T10, na? What is? So T0 is 30, so 1 is 41, so what is the 50? 50 is the T10th term. Is it clear?
Yes, sir.
So now just your problem is now like the previous problem, you have to solve that recurrence relations by using that initial condition, then you have to calculate the T10 and you will get the tiger populations in that year. So here just take it as Tn minus T of n minus 1, and it will be 2 T of n minus 1 and minus 2 T of n minus 2. So it will be Tn minus 3 T of n minus 1 and plus 2 Tn minus 2 is equal to 0. So after that, that is the recurrence relation, that are the initial condition, these are the initial condition, and that are the required values. So these are the problems, and this is a homework for all of you. Okay, I will solve that problem.